Okay, so we got a little bit of practice here on working with our intermediate value theorem, our extreme value theorem, and our mean value theorem, as well as finding critical numbers. So recall that our critical numbers, right, we're going to have critical numbers if f prime is 0 or f prime does not exist, which means we need to find our derivatives. So for this first one, if we're finding our derivative, f prime is going to be 3 times x squared minus 1 to the second power times 2x, using the power rule, using the chain rule. And we need to solve for that being equal to 0. So therefore, 6x times x squared minus 1 quantity squared needs to equal 0. So that's going to be if, let's make this a little bit easier for y'all. This is going to be if 6x is 0 or x squared minus 1 quantity squared is 0. So therefore, x equals 0. That's one of our critical numbers, or x squared minus 1 is 0. So x is plus or minus 1. So we happen to have three critical numbers for our particular function. For the next problem, find the critical numbers of f of x here. Notice that for this problem, it is rational, but our domain is x being an element of the set of all real numbers, and that is because x squared plus 4 is greater than 0 for all x values. So let me find my derivatives. All right, so 8 over x squared plus 4. So f prime of x, right, is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared, right? Now, f prime is going to be equal to 0 if the numerator, negative 16x, is equal to 0. F prime will not exist if x squared plus 4 is equal to 0. We know that x squared plus 4 never is equal to 0, so no critical numbers here. And over here, negative 16x is equal to 0 if x is equal to 0, so that is our only critical number. Okay? Continuing with our work. Number 3, we want to locate the absolute minimum value on this closed interval, and our function is a polynomial. So therefore, we're going to have our extreme value theorem, which means we're going to use our candidates test. Candidates test. All right, which means we need to look at the endpoints and we need to look at the critical points. All right, so we need to look at our endpoints and we need to look at our critical points. So f prime of x, let's see if I can write this a little bit more neatly. F prime of x, all right, let's try one more time. F prime of x is equal to, thanks for your patience, 4x minus 4. We know that that's equal to 0 if x is equal to 1, right? Which means that for our candidates test, we can come over here and say, hey, we have x, we've got f of x, and we're going to consider negative 2, we're going to consider 1, and we're going to consider 2. All right, so f of negative 2. F of negative 2 is going to be 2 times 4 minus 8 minus 2. F of 1 is going to be 2 minus 4 minus 2. And f of positive 2 is going to be 2 times 4 minus 8 minus 2 as well. Okay, so if we look at where our absolute minimum value, right, it's going to be based on this over here. So I know the absolute minimum value is going to be f of x is equal to negative 4, and that is our absolute minimum value. Now, did we have to do calculus here? We didn't. Right? We could understand that f of x is a parabola. It's a parabola that opens upwards. There's my absolute minimum value, and it happens to be at the vertex of this parabola. And for the vertex of this parabola is going to be at x equals negative b over 2a, which is going to be at 4 over 4, so at x is equal to 1, and at x equals 1, the value is negative 4. So our calculus approach, right, our non-calculators calculus approach, so therefore we know that f of 1 is equal to negative 4, and negative 4 is that minimum value. But realize, asks for the value, not for the point. Do not give the point. And the last one for this video, before we continue in the next video with the other problems, we want the absolute extrema for this function on this closed interval. Technically, if we know what this graph looks like, which for this graph, it is a sine function that has been moved down by 3 units. So here I have a sine function that's been moved down by 3 units with an amplitude of 2. So I know that here is negative 3, go up by 2 units, go down by 2 units, and I've got a sine function that on the interval from negative 2, or from 0 to 2 pi, I know that I have an absolute extrema here, and I know that I have an absolute extrema, let's see if I can draw this, down here. Okay, so what does that tell me? It looks like my calculator is slowing down just a little bit, so we'll wrap this question up. Right, so what do I know? I know that the absolute extrema is going to be at pi over 2, negative 1, right, as well as at 3 pi over 2, negative 5. Now, these would be, right, necessary to identify, which is the absolute max, and here is our absolute min. But once again, we did that without calculus. But if I'm going to use the calculus, if I'm going to do the candidates test, I need to find f prime. F prime of x is going to be 2 cosine of x. F prime of x is going to be equal to 0 if x is equal to pi over 2 or x is equal to 3 pi over 2. Then I'm going to want to come in and evaluate x and f of x at the endpoints as well as at the critical points. All right, so I've got the endpoints, 0 and 2 pi. I've got the critical points, pi over 2 and 3 pi over 2. Make my evaluation. At 0, the sign of 0 is 0, so negative 3. At the endpoints, which we could tell from our graph, but 2 pi, sine of 2 pi is 0. And sine of pi over 2 is positive 1, so 2 times 1 minus 3, that's negative 1. And 3 pi over 2, the sign is negative 1, so 2 times negative 1 minus 3, which is negative 5. So from the candidates test, I would have that here is my absolute max, and here is my absolute min. All right, so we get the same result using calculus or not using calculus. We should be familiar with what our work represents and think about, do we always need to do it the hardest way? Well, sometimes yes, sometimes no. Okay, thank you for your time. We'll go over the other problems in the video to follow.